Okay, let's get started. Hi, my name is Lauren Heine, and I am Vice President of the A4 and co-chair with Dr. Margaret Whitaker of the Program Committee, also co-founder with Stacy Glass of ChemForward, a centralized repository of chemical hazard assessments of safer alternatives. Today, we're really pleased to bring to you session 5, Safer and More Sustainable Alternatives, Tools and Strategies being used by the business community. Next slide. First of all, I'd like to thank our sponsors, very generous sponsors, Talk Services, Apple, Department of Ecology, Department of Environmental Quality, 7th Generation, NIH, Angus, 3M, Cyvera, ChemForward, Bolt Threads, and 2 specialty sections of the Society of Toxicology. Thank you for your generous support. Next slide. Okay, session etiquette. We would like you to please keep your lines muted and your videos off. You can put your full name and your organization on your little tagline, and you can change it by clicking on the ... next to your name or image. We recommend that you use the speaker view in Zoom. It offers the best viewing experience. And then during the Q&A period, if you wish to ask a question or offer a comment, you have 2 options. You can raise your hand, or you can put something in the chat. Both are acceptable. And please note that this session is being recorded, and it will be available to A4 members next week. And in 2 months, it will be fully available to the public as well. So to raise your hand, all of these different platforms are different. First, you open the participants icon at the bottom of your computer screen. And then when the participants view opens, you'll find the raise hand icon in the list at the bottom of the icons. So you can click that, and please try to remember to lower your hand once you've been called on. And again, the chat will work also. So thank you. All right, we're really excited about this session today. Before we start, I'd just like to offer a little bit of perspective. I've been around for a while, and remember that back in the late 90s, when there was a shift from focusing on regulating the most toxic substances to identifying substances that were inherently safer. You've probably heard the phrase whack-a-mole applied to regulating one substance only to have it replaced with a regrettable substitution. There were a number of key influencers at that time, including 2 of the keynote speakers for this workshop, Bill McDonough and John Warner. Other leadership came from EPA flagship programs, Green Chemistry and Design for the Environment, driven by individuals such as Paul Anastas, Clive Davis, Charlie Auer, David Fiore, who recognized the importance of designing inherently safer chemicals. The next landmark or benchmark, as from my perspective, was the ability to compare chemicals based on inherent hazard. The globally harmonized system of classification and labeling was launched in 2003. It's updated every 2 years, and now we're on revision 9. REACH legislation was passed with the motto, no data, no markets. So chemical hazard assessment methods like Greenscreen, cradle to cradle, EPA's Safer Choice AA criteria, all built on GHS and added criteria as needed. ChemForward builds on the shoulders of these prior efforts to scale access to this information. And the third milestone was consensus that safer alternatives are not viable alternatives if the only consideration is hazard. They must also be viable with respect to performance, cost and availability, social impacts, waste, exposure across the life cycle, and more. Mary O'Brien's book, Making Better Environmental Decisions, laid the groundwork for AA, as did early frameworks from UMass Lowell and leading to frameworks by the National Academy of Sciences and the Interstate Chemicals Clearinghouse. Today, we have a professional society called the Association for the Advancement of Alternatives Assessment. This is our 4th international symposium. Based on reach, much learning and has occurred. And now legislation, there's a momentum towards regulations to drive products that are safe and sustainable by design. Exciting times. The 4 speakers in this session will share with you how they are advancing both green chemistry and broader aspects of sustainability into their products and initiatives. Each speaker will have 15 minutes, followed by 5 minutes for questions. We also plan to have some time for discussion at the end. Again, please raise your hand or use the chat. We'll start now with Pat Harmon, who's an industry manager for industrial petrochemicals at BASF. And if you'd like to read the full bios for each of the speakers, please go to the A4 website. Pat?
Thank you, Lauren. In the next few minutes, I want to share some of the things that we're doing in alternative assessment, safer chemistries, but then also talk about how this fits in with what we're doing in the area of sustainability. And we kind of, at least in this symposium, are differentiating safer and sustainable chemistries, but they really go together. And I want to talk about that here in a couple of minutes. Okay, there we go. So this slide is a little bit like preaching to the choir. And this is kind of why we do all of this. So one is really important to do informed substitution, know what you're doing, making sure you're doing the right thing. And then secondly, avoid regrettable substitution. Lauren used the phrase whack-a-mole, the magician with the rabbit. I stole from my colleague who more than 15 years ago in Europe was talking about this topic, and he compared it to people alternative hopping. As one substitute started running into regulatory trouble, they moved on to another one, and so on and so forth. And it's a little bit like you're a magician pulling a new substitute out of your hat. And I guess my feeling is this is not magic. It's ultimately science. And through doing this the right way, we can avoid having to constantly be doing a reformulation, which costs money and takes time. And then secondly, I don't think there's any 100% guarantee about avoiding regulatory issues, but we can go a long way to reducing the risk of that. And then the next couple of points are things that I've added for this talk, is that all of this really supports developing of sustainable products. I'll talk a little bit later in the presentation about sustainable solution steering, which is a BASF developed methodology. And it was a way of really showing how using safer materials fits in with that strategy. And then also a big topic right now with a lot of the discussion about recycling is the concerns about legacy additives and other ingredients that may have some, where there may be some concern, what I would call yellow flags or red flags. And obviously, if you're moving to the right sorts of materials now, then you can avoid this issue of reintroducing things back into the supply chain where there might be some problems. And okay. So possible approaches. Again, I think people on this call are familiar with a lot of these. One of these that we've used is Greenscreen. I think kind of two real big benefits. One, it's a full set of hazard criteria. It is a transparent methodology. Also, one of the things I really like is that data gaps are not reported. Very often things may look great, but there may be some data gaps that you don't know about. And I like to tell people that, it's a lot of times the big things are not the problems, or not the things driving the regulatory issues. It's some of the more subtle things. So I think this is one of the real benefits with Greenscreen. More recently, we've been involved with ChemForward that Lauren mentioned a couple of minutes ago. It's a new initiative co-developed with some brands and retailers, which I think is very important because the market pool for safer and more sustainable materials is really coming from that area. So having something that's co-developed, I think is very important. It's a collaborative database of hazard assessments, and I think the collaborative part is really important because you end up having some shared costs. These things, as they're becoming more and more popular, tend to be more and more expensive. And so I think that's one of the real benefits. It uses both GHS and cradle-to-cradle criteria for doing the assessments, which there obviously is overlap between the two, but it gives you a slightly different perspective, which I think can be really helpful. From the classifications, you can develop things into hazard bands, A, B, and C. There's also an F, but you don't really want to be in the F side. But so A, B, and C are examples of safer chemistries. There are, I think the actual number is a little bit larger, but there have been, I think, 15 assessments put in for alternative plasticizers. This is one of the businesses that I'm involved with at BASF. A couple of the products that we promote as alternatives are DOTP and DENCH. They're both in there. And then I call this positive lists, and arguably I think ChemForward kind of fits into this to some extent too. But for the last number of years, I've dealt with, I would call, negative lists. Proposition 65, European substance of very high concern, and to promote something as not being on one of those lists is okay to a point, but it doesn't necessarily say that it's any better or worse than substances that might be on that list. And so I just have a couple of examples that are actually related to each other. One's the EPA Safer Choice Program with the Safer Chemicals Ingredient List, and the Clean Ingredients is a private database of substances that already meet the EPA criteria. One of our plasticizers, platinol DOTP, is currently on Clean Ingredients. And the last point in here, really, which is I think the most important one that I've highlighted, and it's a question of why do we do this? Internally, BASF, we have a large team of toxicologists. I have a colleague who's a toxicologist that works in our business in Europe, who I can pick up on the phone and talk to anytime I want to. But we have to communicate with our customers and also with other stakeholders. I think it was John Warner on Tuesday brought up the point that industry they're being told, yeah, you have to study, you have to know your chemicals are safe and do studies. But then you get the criticism of, well, there are only industry studies available. And this in part is, I think, is a way of finding other ways to communicate with other stakeholders. Also, our customers very often, they may know what we know, but they have to communicate with their customers, and very often their customers are the brands and retailers. And one of my customers said, yeah, we don't require this, but it really helps us being able to promote our products. So, again, I think this is something that will be increasingly important in the future. Okay, so I believe in 2015, BASF introduced something called Sustainable Solution Steering. And kind of the basis of it, particularly then, was an assessment of our portfolio. I think, and we just have been updating it recently. And if you look at the little bullet point on the side, we've done over 98% of our portfolio has been assessed with this methodology. And products are segmented into 4 different sections. And it's really based on what type of contribution they make to the overall sustainability needs. And so we have accelerators, and these are products that have some substantial contribution in the value chain. And then the second group are performers. So that's really the biggest group. And these might be global commodities where BASF maybe does not have any kind of a unique position. There are no there are no red flags from a regulatory or a health and safety standpoint. But they're very important parts of the value chain. And so they're called performers. Then we have transitioners. These are materials that may have some yellow flags or red flags that are being managed, or it may be that there are really no alternatives, and so we have to manage them. And then we have what we call challenged, and these are ones where there are significant concerns of some point, of some form or the other. And if you look at the last bullet point on the right, is we have a target of phasing these out within 5 years after they are identified. And so this is something that's driving our strategy as a company. We want to grow the sales of accelerators. We have a target by 2025 of $22 billion of sales. In 2020, it was we were a little over almost $17 billion. The bullet point I have highlighted, I think, again, is probably the most important bullet on here. This is not just looking at existing portfolio, but it's also being integrated into our innovation pipeline, and then also factors into business strategies and then mergers and acquisitions. And fairly early on in our gated R&D process, future new materials go through this assessment. Obviously, we want to identify anything that could be I would call a red flag, but also we want to identify anything that has a potential benefit. I mean, I think this is something that would certainly support commercialization of the product, and is something that we could promote out in the marketplace. Okay, so the criteria that we use are really based on the UN Sustainable Development Goals, and it's a variety. I won't read through all of these, but biodiversity, renewables, climate change and energy, health and safety is particularly important one. And as I mentioned earlier, really safe and sustainable really go together. We have, a couple of our plasticizers are under this health and safety category. There may be things like renewables that also fit into the safe and sustainable side. And then also, I throw this in kind of as an aside, but I always kind of find this interesting that hunger and poverty are part of the UN goals. And we have an agricultural products group and also a nutrition group. So there are some products and other groups that really address the hunger and poverty issue. So I think there are a lot of needs under sustainability in the world, and there are a lot of different ways of addressing that. And so I think looking at it kind of under the broad sustainability definitions can be a helpful way of trying to understand where the needs are. I mentioned R&D earlier, so I'm really not a big fan of policy driving all of this. The really big driver should be innovation, and BASF is committed to finding some solutions. These are all kind of focused on reduction of CO2 emissions. So some examples of the things that we're working on: a new process to produce hydrogen, electric steam crackers as opposed to natural gas-fired steam crackers. We currently have a joint venture with, I believe, at least 2 other companies. And then lastly, an alternative route to synthesis gas. Synthesis gas is carbon monoxide and hydrogen, which is a building block for a lot of chemistries that we're involved in. So this just gives a little bit of minor detail. Right now, your feedstocks, whether it's naphtha or lighter materials, are fed into a natural gas heated steam cracker, and then olefins, ethylene, propylene, and others are produced. There's a lot of CO2 emissions that come out of this. And with the e-cracker, with the electric cracker, you're using renewable energy. My German colleagues don't really like nuclear, but I would probably put nuclear in here. Let's say low emission energy sources to do the same thing. And it's not zero CO2, but it's a much reduced amount of CO2 that comes out of that process. And then in terms of raw materials, a couple of different routes that we're working on. One, in terms of renewable feedstocks, it could be dedicated bio-based portfolio. The example here, I had to think of what RSPO stand for, but I think it's responsibly sourced palm oil. So palm oil is one of the feedstocks that other groups in BASF use. We obviously have some bio-based plastics, PLA based products, and then also we're also using the biomass balance approach. So this is biomass waste is fed into our crackers, and then through kind of an accounting process, businesses can buy credits for biomass balanced products. And it's a little bit like if you go with an electricity provider that is providing renewable energy, the material that you that you are getting maybe no different than what your neighbor's getting, but obviously the company you're buying from has bought credits to be able to say that they're 100% renewable energy. Very similar type of thing is being used also with what we call chem cycling. The more generic term is advanced recycling. And their post-consumer plastic waste and tires are used to also feed into very similar processes to be able to make new feedstocks for making various products. And this is I think people are always looking for the one silver bullet for plastic waste issues. And I think the real answer is there are going to be multiple ones. And this is particularly, I think, a solution for materials that are hard to recycle. Maybe they're multi-layer products, or the ones that are just kind of inherently contaminated and can't be easily go into mechanical recycling systems. Okay, so closing minutes, I really want to focus on what I consider to be the challenges. One are data gaps, and I think there's a talk this afternoon, or at least after this call, on alternative methodologies. I think this is going to be essential. It's very expensive developing toxicology data, but I think if you're going to do the right kind of informed analysis, you really have to address this. And so I think future continued work on these new methodologies will be essential. Priorities. I think this is a major issue. It's like what are we going to work on? One of the speakers on Monday talked about hazard and risk assessment. I think both are important. And sometimes I think we have to kind of really understand the risk to help us prioritize what are the things that are most important to work on. And then I call this working on real problems and not just invented ones. There's a new publication this week where they're looking at fast food products. They're looking at particularly plasticizers in fast food. And if there were a number of media articles, but if you actually read the paper, in most cases there were non-detects or there were double-digit parts per billion levels found. I think the highest levels were in the single-digit parts per million. And this analysis also included some of the alternatives that I mentioned before that are Greenscreen assessments listed in ChemForward. And I think if you read the media attention for media articles, you would think that this is the #1 green chemistry challenge in the world. But if you look at the paper, and then the authors even kind of provide this kind of context, it's all kind of nonsense. I mean, you're talking about very, very low levels, and particularly in most cases of substances that are, clearly you would include in the safer chemistry discussion. And then lastly, innovation. As I mentioned before, this is really, I think the driver. And I think when you start talking about innovation, it's timing and cost are really important. It's all this costs money. It takes time. My colleague, but I think it's something that is kind of inherent to many of our companies. We've been doing innovation for more than 150 years. And that's why we've stayed in business this long. And so I think we'll continue doing that. The other is, I think we really have to focus on innovation and making that kind of the driver and not just trying to be sustainable. I think when we do innovation the right way, then we're using the right materials, the right processes in order to do that, so that the products will in the end be not only sustainable but also innovative. So anyway, that concludes my talk. I look forward to the discussion coming up in a few minutes, and answering any questions you may have.
Thank you, Pat. That was terrific. I am going to ask one question. Sorry, Molly, we're going to save all the other questions for the end, but there's one that's just very timely that Carl Palmer asked. You mentioned that you weren't a fan of policy being a driver, but rather focusing on innovation. Can you provide perspective on how regulators could then promote innovation? And we'll save the other ones to the end.
Yeah. But my own kind of personal view is, I guess, two opposite things. One term that I really like is permissionless innovation. So regulators can stay out of it. But at the same time, I think because of the cost, obviously, and I think for many years, we've continued to fund research. And I think continued funding for innovation, I think will be a big part of that.
Okay, thank you. All right, I'm very pleased to introduce our next speaker, Victor Zanchi, who's the Product Sustainability Manager for Reckitt. Victor?
Thank you very much. So it's a pleasure to be here. Let me make sure I can, yeah. So I'm going to go through a little bit of our journey as Reckitt on ingredients in general, and talk through our sort of 2030 ambitions, broadly from a sustainability perspective, but also focusing on ingredients, and then dive into the main tool that we have for that innovation, which is Sustainable Innovation Calculator. I have a couple of case studies to highlight how that's being used in the business and some of the challenges that then go with that. So for those of you that may not recognize the name, you probably know us from our brands rather than necessarily Reckitt itself, but we are a global fast-moving consumer products company, and we operate all over the world across the three business units, essentially: hygiene, health, and nutrition. So we have a very broad portfolio that brings its own challenges in terms of how we manage that portfolio in terms of ingredient challenges, regulatory challenges, and so forth. And really, from an ingredients perspective, as I think a lot of the industry has been focused on compliance and making sure that products are safe for the consumer, but we have always, for a good few decades even, have an internal restricted substances list. So we've been managing that internally on ingredients that cannot be used, and having that very focused compliance lens. And in recent years, as we start to develop that sustainability strategy, we've also started focusing on chemical footprinting, both to gain that broader understanding across the whole company of where potential issues might have been, anticipating regulation, and being able to focus on innovation. And with our new sustainability strategy, we are very much now focused on embedding that sustainability by design into how we develop our products and the innovation that we do, incorporating those green and sustainable chemistry principles. So I've mentioned it a couple of times, but in March of this year, we launched our new sustainability ambition for a clean and healthier world. And that sort of company purpose, fight and compass are at the core of what we do. And it means that we have a very purpose-led business strategy. And these sustainability ambitions are an integral part of that. So we are committed to ensuring that our products achieve some of these ambitions around our net revenue coming from more sustainable products, carbon footprinting, our use of virgin plastic, but there is a reduction in our chemical footprint as well. So we are looking to shift towards better chemistries in our products. And this strategy then is embedded at every level of the business, and with these goals, we break those down from corporate level targets into brand level priorities, and our brands are very much aligned with a purpose that then connects into the sustainable development goals. And in order to enable that product development to align to that purpose, we have this Sustainable Innovation Calculator, which empowers our product development teams, our formulators, packaging engineers, marketeers, to understand the sustainability impacts of the products that they're working on while they're still designing it. So it's very much trying to embed that sustainability and by design. And the calculator has been in use since 2013 and was very much originally focused on carbon, water, and packaging. It does follow life cycle assessment principles, but using a simplified approach. And this early this year, we've made a number of updates to incorporate then some of those ambitions. So we've incorporated more complexity around the plastics side of packaging, but we've also worked on a new ingredient metric. Now, an important thing to note here about our tool is that it is comparative. So not only does it compare the current innovation against a previous benchmark, which might be a previous version of that innovation or a previous version of that product, but it could also be a benchmark product that delivers the same result. But we also assess that on a dose basis. So a dishwasher load or a meter squared of surface clean, for example, or 24 hours of pain relief. So that allows us to compare like for like and really show progress over time in terms of our innovations. And there's a bit of more technical detail behind each of the broader metrics, but I'll focus more on the ingredient one. But we are measuring carbon, water, and to some degree the packaging angle as well, since we started using that tool in 2013. And it very much focuses on the scope 1 and 2 of the products, looking at raw materials, looking at the manufacturing angle of it, as well as incorporated to some degree, although we do measure that at a corporate level as well. And it is very much a tool for innovation. So it is intended for our product developers to use as an experimentation tool. So they can go through what-if analysis, swap materials out to understand then that impact that specific material choices might have on the overall performance of the product. But it also allows them then to have a conscious effect on the performance of the product, and also understand those drivers behind those impacts. So it allows them then to explore what is driving each of those of that impact. But it is also a tool that is available across the whole organization, across all of the R&D teams. and it is very transparent within the organization. So it does allow teams to collaborate and take ideas from one innovation to their own. And while it's not enough to support claims, the methodology does allow product developers to identify where claims may be worth pursuing with perhaps a full detailed life cycle assessment, for example, or going into more depth than the simplified tool allows. And ultimately, each assessment through this tool is going to mark a product or a project as either more sustainable than its previous iteration, as sustainable or less sustainable. And we then report this internally at a brand level for the whole product development pipeline. But we also use that to assess the share of Reckitt's sustainable portfolio. So the share of our net revenue that is coming from those more sustainable products. And as you can see, we've been making steady progress over the last few years, and we achieved in 2020 30% of our net revenue coming from more sustainable products according to this tool. Now, Reckitt doesn't manufacture chemicals. We are a product formulator and a manufacturer. So we had to look at the principles of green chemistry and try and implement them and adapt them to support our product developers in their formulation. And the way that we've done this is combine them essentially into three pillars. The first one is around thoughtful design, making sure that our products are safe by design, but also don't have a negative impact on the environment. So this is around safer chemistry, design for degradation. Constant improvement is the second pillar. So this is progressively using purer, simpler materials, so fewer chemicals or fewer materials in products with less waste and a smaller footprint. So reduced complexity, reduced waste, smarter use of chemistry, so using catalysts in some of our products, for example. And ultimately innovating sustainably. So it is not just about business as usual, it's about embracing new technologies that are regenerative. So both in terms of energy efficiency, but also renewable feedstocks for our materials. And as I mentioned before, we have developed this additional ingredients measure within this tool that is new this year. And here we've taken those three pillars and developed the 4 KPIs or four buckets of KPIs that we then use to assess our products. The first one is around safe and effective alternatives. So all of our products are, of course, assessed for their safety and risk assessed. But here we are looking at the inherent hazard of the materials that are going into our products. So both from a human and environmental perspective. We're also looking at the efficacy of those materials in the product. So it is about safe and effective alternatives. The second pillar is around circularity and feedstocks. And we're looking here at both the origin of the feedstock. Is it bio-based? Is it mineral? Is it fossil? But also the circularity. So is it virgin material or is it derived from waste? The third is around biodegradability, which is fairly self-explanatory, but most of our products do end up going down the drain, so to speak. So they end up in the environment. Therefore, biodegradability is a very important measure. And finally, we incorporate chemical footprint into the calculator as well. So this is looking at external lists to understand where there might be an authoritative pressure, whether it's a developing policy area, but also looking at the screening lists so that we can understand the future potential impact on our products as well. Now, there is a lot of data that sits behind these KPIs. And as I'll go into a little bit more detail, data is one of the greatest challenges. But here we've got some partnerships, and we have tried to secure that data wherever available. So for safe and effective alternatives, we've got a partnership with ToxNot to bring in Greenscreen and its translator scores for our materials. For circularity, most of that is coming either from common production routes or from supplier data. For biodegradability, we're taking that from publicly available data from the European REACH process. And again, chemical footprint is fairly straightforward in terms of looking at those external lists. But it is important here to note that obtaining that data from supplier is key, and that is always going to be the best quality data that we can use in this assessment. Finally, just to note that all of these dials around carbon, water, plastics, ingredients, and so forth are combined then to give that overall score for that product. And we use a points-based system here to result in either a more sustainable, or less sustainable product. But these are all working with each other. So we're looking at across all 5 of those dials to give that final result. So how does this actually potentially be used from an R&D perspective? So I have a couple of case studies that I'd like to go through. The first one is where we already have a material that is qualified in our business. And the example here is we're looking at to replace a petrochemical surfactant with alternatives that are bio-based and have few inherent hazards. So there's a broad range of possible alternatives already in the business. So how do our product developers assess these materials against this particular product? And here we can use the Sustainable Innovation Calculator to identify alternatives that are already being used in other projects. The teams can then do a what-if analysis and comparing each of those possible alternatives and seeing what effect that has within the overall performance of the product. And in this particular case, a lead alternative was identified that uses is a bio-based surfactant that's already qualified elsewhere in the business. Where we potentially have a brand new material. So in this case, the team is looking to identify more sustainable solvents to improve the profile. We already have a partially bio-based material in use, but the team wanted to explore increased bio-based content, alternative feedstocks, improved biodegradability, as well as a reduced inherent hazard. And all of this while maintaining or improving the technical specification of that material. Now, because we don't have this already in our systems, a review of our calculator was not possible because these materials are new. So the team then has had to explore partnerships with both our current suppliers and new, looking for innovative materials where available. But here then it is about the assessment of the technical parameters for feasibility. And here is where the data from suppliers is absolutely critical. So requesting data on life cycle assessments, certification where appropriate as well. And that technical review takes place in parallel with the sustainability review of all of that material. And as I've alluded, data is probably one of the key challenges from our perspective, in particular when it comes to our assessment of ingredients. Hazard data is relatively easier to obtain, but only if we have the full composition of our raw materials provided to us by the suppliers. So where we don't have trade secrets or materials that are deemed by the supplier to not be hazardous and therefore not fully shared. Biodegradability is slightly more challenging, except where perhaps there is a legal obligation in terms of surfactants, for example, or where materials are being marketed as biodegradable. And then on bio-based, regenerative, renewable carbon, that is even harder still, especially where we see mixed supply chains, where we have partly bio-based, partly petrochemical, and understanding that mass balance, and that's usually the best that is available. But there is great potential here for harmonized certification across the industry for that renewable carbon content. And then finally, carbon and water. While we may be able to get that at an organizational level, it's harder to obtain that from a specific material perspective, and we have to rely a lot on generic emission factors, for example, from databases like EcoInvent. And then finally, the other great challenge is around complexity and those trade-offs, and actually communicating that complexity to our product developers to help in their decision making. Here, alignment with the brand purpose is key. And understanding that a bio-based feedstock may come with a higher carbon or water footprint, whether that's acceptable will depend on that product's place in society. And the challenge then is how do we make that what is essentially a subjective choice clearly measurable? So with that, I'll conclude.
Thank you, Victor. Well done. Really rich presentation. We have time for one brief question. Does Reckitt consider, this one is from Topher Buck from DTSC, does Reckitt consider the biodegradability of packaging materials as well as products?
So packaging is considered separately from ingredients, but it's considered within the overall assessment of the product. And here we consider it depends a lot on the purpose of the packaging. So we consider reusability, we consider recyclability, we consider incorporation of recyclable content. Most of our packaging isn't going to be intended to be biodegradable because we much prefer it's recycled. We don't want it to end up in the environment. We want to facilitate the recycling. We want to facilitate the reuse of that packaging.
Great, thank you very much. Okay,
thank you.
I'd like to introduce our next speaker, Sandra Meijer, Director of Product Stewardship from the Yordas Group. Thank you, Sandra.
Yeah, thank you, Lauren. Great to be here. So for those of you who don't know Yordas Group, we are a consultancy firm supporting industry with chemical regulatory compliance and sustainability. And we are headquartered in the UK, but we also have offices in Canada, Germany, and Turkey. And we are involved in a wide variety of projects around safe and sustainable chemistry, often working with clients, but sometimes also in government-funded projects. So today, I just want to share 3 of those projects with you all. And I don't know if I can change my slide. Yes. Oh, too far. The first one is about safe and sustainable by design in the field of nanomaterials. And this is some EU-funded projects that we're involved in. Then I want to present a case study. It's an ongoing project that we're working on with the client in the retail sector about sustainable solvents. And then I will finish with some thoughts about predicting regulatory risk and the work Yordas is doing in that area. So safe and sustainable nanomaterials. So just a bit of context around this. In the field of nanomaterials, there's this concept of safe innovation approach. And it's basically a framework outlining the necessary elements needed to achieve safer nanomaterials and nano-enabled products. And it says that new materials must be functional, safe, sustainable and circular, compliant with regulation, accepted by consumers, and cost-effective. There's some key drivers, for example, the Green Deal, the circular economy, and the chemical strategy for sustainability. And this new EU chemical strategy for sustainability aims to catalyze the shift towards chemicals, materials, and products that are inherently safe and sustainable throughout their life cycle. And on the right-hand side of this slide, you can see some of the key tools that they've identified, such as risk assessment, life cycle assessment, safe by design and sustainable by design, which together really form safe and sustainable by design, and regulatory preparedness. And the safe innovation approach combines this safe by design with regulatory preparedness. So the criteria for safe and sustainable by design that were identified also in the same nanomaterial sphere is that they should be safe, circular, and functional, in short. Now, and this is obviously makes complete sense, but actually implementing that, is not that easy. The nanomaterials are often still in the innovation stage, and therefore, obviously, it's a perfect opportunity to make sure you get it right first time regarding safety and sustainability. This is in contrast, of course, to established chemicals that may have been used for many, many decades and started to be used even before anybody looked at safety. So that's obviously a great opportunity for nanomaterials specifically. And so some of the projects that we're involved in are really at the forefront of trying to define and implement this safe and sustainable by design concept. So the first one's called Sunshine, and the aim of this project is to develop safe and sustainable by design strategies for multi-component nanomaterials. I've put the links to the websites here for people to maybe look them up later, because I don't have time to give lots of detail. The other project is called SBD for Nano, or Safe by Design for Nano. And the aim of that one is to create a novel e-infrastructure for the definition, performance, testing, and implementation of safe by design approaches in the nanotechnology supply chains. Now, these projects are all still ongoing, so I can't really give any concrete outcomes of these projects at this moment, but I will leave you with this slide with also the link, which is the Safe Innovation Approach Toolbox website. This was put together under the NanoReg 2, also an EU funded project, in collaboration with RIVM, which is the Dutch National Institute for Public Health and the Environment. And here you can browse safe by design tools and case studies, and also the future outcomes of the various ongoing projects on nanomaterials will feature here in due course. So the next topic I want to talk about is sustainable solvent projects that we have been working on with Kingfisher, which is an international home improvement company operating in 8 countries across Europe under retail banners such as B&Q, Castorama, and Screwfix. And the initial stages of this project were delivered together with the Green Chemistry Group at the University of York in the UK. So, oh, too far again. Oh, why can't I find where to go? Oh, got it, sorry. There. The background of this project is that Kingfisher was looking to develop a more sustainable range of home improvement products. And obviously it's well known that solvents are often hazardous to human health and environment. So this project was started with the aim to remove hazardous solvents from some of their product ranges. But you can't just remove the solvents, as we all know, because then the product doesn't work anymore. And if you substitute, you have to make sure that the new product with the alternative substance still maintains its functionality. And retailers are not experts on chemicals and on formulating products for specific functionality. Their own brand products are usually made by contract manufacturers, and they are the ones who are best placed to come up with safe, with the chemical alternatives. But obviously you then have the risk of regrettable substitution, and we don't want that. So there is a very clear need to be very clear to the vendors about the acceptability of some of the alternatives that they might be looking at. So this is really about, it's kind of safe and sustainable by design, but it's more like redesign, because they're trying to redesign, you know, already existing products. So what we did is, in the first stage of the project, we came up with an initial list of solvents. And these were solvents that we know are used in product like the ones in Kingfisher's product range. And we used a variety of online sources for that, including our own chemical database, Yordas Hive. Then once we had the initial list of solvents that might appear in their products, we then, in stages 2 and 3, we simultaneously did a regulatory assessment and a green chemistry assessment. So in the regulatory assessment, we looked at various listings of chemicals and assigned them to some of the lists were in the do not use category and some in the problematic category. And then the substances were given an overall classification based on their worst case listing. And then in the green chemistry assessment, we used the Chem21 tool, which was developed by the University of York. And each solvent there was assigned a safety score, a health score, and an environment score. And then both these assessments were combined to create the master list of solvents, and each solvent was assigned to a category: acceptable, problematic, and do not use. So those 4 stages of the project are now complete. And now we're on to stage 5, and Kingfisher really wanted to look at things in a bit more detail. So basically what we're doing is a repeat of stages 2 to 4, but this time we're looking at it from a product specific angle. So basically what happened is that there are cases where a substance ends up in the most severe category due to being restricted in a specific application, but it could potentially still be used in other applications. So the initial master list that we came up with is actually based on hazard alone. So this time we wanted to take into account risk through exposure. So we're looking at 3 product categories. Sorry, the slide's gone a bit funny. Cleaners and care, adhesives and sealants, and paints and coatings. And so this will allow us to have certain use-dependent exemptions from the either the do not use category or the problematic category. So yeah, so this is all still in progress. It's a little bit more complex than doing it just on a hazard basis alone. But the expected outcome of the project is to have a transparent methodology that will enable constructive dialogue between Kingfisher and suppliers in order to phase out the most hazardous solvents. And by using a product and application specific approach rather than a blanket allocation in a particular category, this does provide a bit more flexibility. Okay, so the last topic I want to talk about is predicting regulatory risk. So we've already seen in the other 2 topics that regulatory status always plays a role, for the obvious reason that whatever conclusion you might reach about safety and sustainability, the legal requirements always have to be fulfilled. And potential future regulation is a big risk for businesses. Changing in regulation means that the goalposts are constantly being moved. And this also comes back to this idea of regrettable substitution. You don't want to replace your substance with one that itself will also be banned further down the line. So wouldn't it be good if we had a crystal ball, one that could predict which changes to regulations would occur in the near or even the far future? So unfortunately, I don't have a crystal ball, but we do have a great team of data scientists at Yordas, and we have a very extensive data set for them to work on. So what is this data? So we have been compiling our internal database that is also used by industry through the Yordas Hive application since even before 2012, but in 2012 is when we started in earnest to scan regulations on a weekly basis for any changes that were happening to substances. So at the moment, we have a database covering over 270,000 substances and more than 1,500 regulations. And we have been recording real-time updates to this database since 2012. In the beginning, the data was a little bit sparser, so our kind of high quality data set of structured records of substance and regulation updates is since about 2015. And so what does that mean in terms of the data we have? Well, if you look at our data in this time period, we have recorded 212,493 revisions to substances, which equates to about 101 per day or 36,865 per year. That's a lot of data. The substance with the most updates has had 66 updates in that time, which is a time period of 6 years. I do have to put this into a little bit of context because there's lots of substances there, and actually 97% of all the substances in our database have had fewer than 5 updates. But even so, there is a good proportion of substances that gets updated a lot. So what have our data scientists done with this data? Well, first of all, they started visualizing this data, and it's a powerful tool in itself. So, for example, this is just an example of a few substances. We call this time series analysis. So here you've got the years. This is basically the date on the bottom here. And every line is an update. So if you see a thicker line, there will have been several updates in a short period of time. And so we have here a time series analysis from 2012 to 2021 for PFOA, and here one for DHP. And it's quite interesting. You can see that DHP had lots of activity in this kind of 2015, 2016 time. Whereas PFOA is really accelerating even up to the present day, and that will probably still continue. So that in itself already is a really nice way of visualizing the data and being able to take some conclusions from it. And then the other thing they have done is build a predictive model. So we're still working on this, but it's showing great promise. So this, for example, is substance chromium trioxide. It has had 62 updates since we started measuring. You can see here where the last update was, and it gives you an update probability. Don't ask me how the model works because I don't understand it, but our data scientists do understand it. And so in itself, this number maybe doesn't mean that much, but if you do a comparative, if you look at lots of different substances and rank them according to their update probability, then it really starts to give you some good idea. So this is a project that's still ongoing, and we'd be really interested to hear some thoughts from people about this. And that's the end of my presentation. Thank you very much.
Great. Sandra, thank you so much. That's fascinating. You do have a little bit of a crystal ball there. All right, one quick question here. Regarding this is from Antonio Quinones Rivera. Regarding the time series analysis, have you been able to determine what are the events that precede and perhaps trigger those regulatory updates?
Yeah, that's a really good question. And actually that is part of a follow-up project that we're currently speccing out, because sometimes you can see that, but we haven't analyzed it in detail. I mean, I have an example from, this is completely different project, but we have been working with the tire industry And there was a science paper was published maybe last year, when they found a new chemical that was killing the salmon in the waterways, 6-ppd quinone. And we've been monitoring that as well. And you can see actually how that publication then triggers enormous media attention, which then triggers new regulation. It was in California, they put a new regulation in place. So that was a really, really great way of seeing that. But on this data, we haven't done that yet.
Fabulous. Thank you so much. Okay, I'd like to now introduce our last speaker for the session, and that is Scott Echols, who is Senior Director of ZDHC. Thank you so much, Scott.
Oh, thanks, Lauren, for the introduction, and thanks to A4 for inviting me to participate in this. It's, the presentations by Patrick and Victor and Sandra couldn't have actually been a better setup for what I want to talk to you about, because a lot of the information that they brought to light and what they're trying to do is what we're trying to do on a very global and large scale through ZDHC, the roadmap to zero. But I need to give you a little bit of background. Some of you may be familiar with ZDHC, some of you may not. So I need to give you a little bit of background and context about where we came from before I can get into how we're addressing a sustainable chemistry and really trying to move people beyond just getting rid of banned chemicals. So the ZDHC effort really came out of the result of probably a Greenpeace campaign back in 2011. And I was at a major brand then, and they really campaigned and pointed out a lot of the weaknesses in what to date the system we'd set up, where we were trying to engage at the product level and keep restricted chemicals out. But they pointed out there was a lot of weaknesses in that approach. And as a group, the brands that started, the 6 brands that started ZDHC, really recognized that this is too big of a challenge to address individually. It required collaboration, it required transparency in the supply chain, and it required a commitment from each of the brands to really carry out and really walk the walk and not just make commitments and then kind of let the commitment sit there. It really required the industry to change. What started out in 2011 as a group of 6 brands that met informally and then formally with an advisor group that kind of managed the meetings has now grown to, as a foundation in 2015. We started out with a staff of 4 and a board of directors, and we now have over 160 contributors. And you see the logos of those contributors there ranges from the brands that we have, brands and retailers, the chemical industry, the textile and footwear industry represented here means the actual suppliers, the people doing the work on the ground to make the products. Solution providers are an important component of this, the people that are doing the analyses, and then a lot of associates, because there's no way we can possibly engage every supply chain everywhere in the world in the fashion industry. We need to work through local trade associations and get them involved to be able to really have a widespread adoption of what we're trying to do. And what are we trying to do is we're really trying to move from this place of product compliance, which is where I started about 20 years ago working on these type of projects, where we were just really trying to get our hands around how can we make sure that the products are safe for the consumer, that they're meeting the regulations that are out there, to something that becomes a proactive supply chain management has innovation and leadership, and where the supply chain, you're not just doing this and trying to catch the problem at the end. It's how do you take these problems and eliminate them at the point of production, and how do you make sure that the products are safe, not just by having a restriction on the product. And I have to say that it's also important for those of you that aren't familiar with the fashion industry, the footwear industry. we were starting from a pretty low point, honestly. Formulators like Reckitt and others, and certainly chemical companies like BASF, all those products, they have a high degree of specificity related to the chemicals. They know what they're formulating. They have a recipe. The textile industry, this shirt I'm wearing, there's a lot of ways you can get that color, that you can get the feel. The consumer doesn't notice whether you're necessarily using the correct legal chemistries, and they don't recognize that you can't tell in the product whether it was created in a way that didn't pollute the environment. So we started from a pretty low place. And in fact, when I started with that brand about 12 years ago, we were told from the sustainability standpoint, in no uncertain terms would we ever be able to dictate what chemicals our suppliers could use. And that's changed completely in 12 years to the point where ZDHC is really focused on getting the suppliers the list of chemicals that they can use, and the brands are behind that and actually really trying to drive this idea of a positive list of chemicals that can be used. So it's quite a change that's actually occurred in the last 10 to 12 years for this entire industry. But we started from a very low spot. We started at a place where we were lucky to have safety data sheets for a lot of the chemicals. And what we're trying to do is really align many frameworks under one global network so that it reduces the cost of the suppliers. Most of these suppliers are working for multiple brands. So to have different brands coming with slightly different requirements, or maybe no requirements at all, it's difficult for the suppliers to keep up with that and comply with it. And as I was listening to the talks today, and as I looked at the list of attendees, it would be kind of like taking everybody that's on this in this meeting and aligning all of your tools and expectations for those tools into one common framework and then trying to advance that. And that's really what we're trying to do. So as we thought about what is the mission of ZDHC, once we got through the initial part of the campaign, and I have to tell you, ZDHC actually stands for Zero Discharge of Hazardous Chemicals, which was the original commitment of all the brands. We thought about, well, that's probably not even audacious enough. What our goal should be widespread implementation of sustainable chemistry, so to drive those innovations and really best practices into the whole supply chain, supplying the fashion industry, so that we're making sure that we're protecting consumers, but also the workers and the environment. So we have a very big vision for what we're trying to do. And how do we do that? There's no way I can hope to go over the whole complexity of ZDHC in this call and address the issue at hand on sustainable chemistry and chemicals from a hazard standpoint, but I can give you a quick overview and then focus in on what's really critical to the topic at hand. This is kind of a complicated chart, but if you start at the top, we're really driven by the brands, our contributors, what we call our friends, people who are using the tools, but maybe not contributing directly in terms of development of the tools. We develop the tools through the ZDHC program. And if you read counterclockwise here, that's setting the requirements. So we say what chemicals are banned and also what can be used. The chemicals that can be used appear in our gateway. It's a database of chemicals. I'll give you a little more detail in a minute. We invite the suppliers of the brands and the contributors to access the gateway to look for the chemicals that are better to use. They can use what's called an in-check report to report out on the inventories that they have to the brands and give the brands a sense for, are the suppliers meeting the requirements for what chemicals are being used. At the supplier level, we have, that takes care of the input. We also are worried about the processes. How are the chemicals that should be used in the factory actually being handled? Are they doing the right things with respect to everything from water to wastewater treatment, energy? So we have a program called Supplier to Zero to engage the suppliers and get them involved and really make it something that they can take charge of and act on, and connect them up with people that can help them. We have a ZDHC Academy, which is trainings and learning about, how do I set up a chemical management program in my company? How do I look for these banned chemicals? And then we want to check the outputs. So we want to see, are we making any impact at all? And this started with our wastewater program. We have a list of wastewater requirements for the facilities for not only the banned chemicals, but also the things that are the traditional conventional pollutants, like total dissolved solids or biological oxygen demand. And the suppliers can again access a report called the Clearstream report if they upload their wastewater data to the database, and they can share that with multiple brands that they work with to try to minimize, again, this repeated work that the suppliers are doing to satisfy different requirements across the supply chain. That information for the wastewater can get reported to the gateway. The information on chemicals use goes into the gateway, which can then, again, go back into reports which inform the brands and the contributors. Then we take that into account and we can make program changes to adjust. Are we missing something? Do we need to adjust parts of the program? So that's a really fast tour of what we're trying to do, but it gives you a sense we're trying to address the entire supply chain, engage all the actors in the supply chain, but also engage with the inputs and the processes and the outputs. And that's what we really believe is important, is this holistic approach to sustainable chemicals management, not just giving somebody a list of don't use these chemicals, but actually helping them find alternatives, helping them understand how to store the chemicals they're using safely, how to use the chemicals to minimize the resources they're using, and then how to check what they're doing through the outputs, through water. We will have an air emissions document coming out. But we believe that this holistic approach is really what has to be done to address this problem. A little bit deeper dive on the input side of this, we have what's called our ZDHC MRSL. That is a list of banned, restricted chemicals in the supply chain. They shouldn't be used at the facility level. Now, ZDHC doesn't offer certifications, but what we do is we've tried to, through our ZDHC conformance process, grant acceptance to what we think are credible certification systems to say that the chemical should meet the ZDHC MRSL requirements in terms of not containing a banned chemical at a certain level. All that information is used then for a chemical supplier, for instance, BASF, can upload chemicals that meet the ZDHC MRSL as evidenced by these third-party certifications onto the gateway. And then those can appear to the suppliers. So if the supplier needs a surfactant or it needs a degreaser to treat cotton, they can go onto the gateway, they can look for that particular application they need, and they can see all the chemical trade names for those formulations that meet the ZDHC MRSL. So they don't have to deal with interpreting this list of several hundred chemicals and trying to figure out where it might occur. They can simply go look for the alternatives formulations that meet the requirements. And then we have reports coming out of that. I mentioned the NCheck report before, that the supplier can share with their brands to show what percentage of their chemical inventory meets the requirements of ZDHC. But for the chemical suppliers as well, we also thought it's important. I'm sure Patrick at BASF, they deal with multiple certifications. What we've tried to do is align under a common framework that certain certifications are more or less equivalent. They may not be exactly the same, but they would provide the same degree of assurance. So you might have a Blue Sign certificate for one chemical, you might have an Okotex certificate for another chemical. Why require the chemical supplier to go ask for all the certifications available? Let them get the ones that work in their system and then allow them to report out to the suppliers through this ChemCheck that they meet the requirements of the ZDHC MRSL. Again, trying to align systems and reduce duplication that doesn't really add to us making a real impact. As I mentioned, this gateway is pretty much the largest database of safer chemistries, safer being that they meet the MRSL, that's available to the industry. We have, this was data that I had pulled up that was from a presentation back in April, but at that point we had over 1,500 formulators had accounts on there, so chemical formulators. and we had about 55,000 chemical products that had been published to the gateway. So it's a large database, and the supply chain should be able to then more easily access the alternatives rather than just trying to play a guessing game with a list of restrictions, or simply rely on maybe it's not even a certification, maybe it's a self-declaration from the chemical supplier that it meets the requirements. This is a database of things that have a third-party certification that it meets the ZDHC MRSL. But how does that really get us to more sustainable chemistry? Obviously, I've been talking to date about this MRSL idea that it's the banned chemicals, and they're the common chemicals that are on most people's lists of restricted substances. So how do we get beyond that, and how do we actually cause the system to change? Because it's one thing to put this out there and everybody says, oh yeah, we're going to do this. We're on board with it. But it's another thing to really get people to act and to really make sure that the follow through is there to get this implemented in the supply chain. So what we try to do is have set up a system that's a self-reinforcing system where we have what's called a leader program across the supply chain. So for the brands, we have what's called the Brands to Zero Leader program. And in that program, we review every year their activities in terms of, how have they implemented the ZDHC tools? Have they asked their suppliers to meet the ZDHC MRSL? Have they made public commitments on the ZDHC MRSL? Have they asked suppliers to carry through with wastewater testing? All those things that are in our program, they get scored on that. And the more that their suppliers are using chemicals that meet the MRSL and go beyond that, the higher their score is internally. That in turn drives them to go to the suppliers and say, we need you to use more chemicals that are meeting the ZDHC MRSL. We need you to use more sustainable formulations. That fits into our Supplier to Zero Leader program, where we're really looking to engage the suppliers and again, allow them, the ones that are very far advanced in their journey on sustainability, to really be rewarded for that and be rewarded as aspirational if they're using a high percentage of chemicals in a safe way that not only meet the MRSL, but go beyond that. That in turn then enables the suppliers, they go to the chemical suppliers and say, we're looking and we're going to purchase these formulations that meet the MRSL and are more sustainable. One of the things that I've commonly heard over the years is that, well, there's a lot of sustainable chemicals out there, but nobody's asking for them. And what we're trying to do is get the suppliers to ask for those, to then make that business case to the chemical industry that more innovation is needed, and that when they do that, there will be somebody there to use it. So our formulation to zero is based on a foundational, progressive, and aspirational levels. The foundational level is it has to meet the ZDHC MRSL. There's no exception there. They have to be responsibly produced. You can't just have the chemical meet it and not have the responsible production. And the chemical company needs to have toxicological expertise in-house to be able to credibly create everything from a safety data sheet to supplying information to companies like Greenscreen or the ChemForward program, so that if they do participate in those programs, they actually can provide credible data. Progressive is then looking at how does the chemical react on the product? Does it give good product performance? Does it really limit the risk of an RSL failure at the product level? Because there are some chemistries that are applied that they have to react, and then you have to check the product. But then aspirational is where we really want to drive to, and that's, are they demonstrated safer and more sustainable based on a scoring? In other words, if I have a choice of 5 different dye stuffs that could make this red shirt, which one should I choose? Should I, if they're all equivalent from they all meet the MRSL, they all meet the baseline, How do I know which one is actually safer from a hazard profile? Which one uses less water? Which one uses less energy? Which one is better for a circular economy system? And that's where we want to go with this. So our idea at the aspirational level, and there's more detail behind this, but I can't quite share it all yet because we're still, as I said, we've got many players across the supply chain. And what we're trying to do is get everybody aligned so that we come up with something that meets everybody's needs, but also has an aspirational component and really pushes people. But we feel that we need to have a scoring system that's across these categories. There may be others that we end up including, but certainly chemical hazard assessment is one of those. Exposure potential, how much energy is it using, how much water, recyclability. And I think you can see this looks an awful lot like the sustainable solution steering that Patrick was talking about, or the sustainable innovation calculator that Victor was talking about, and the safe innovation approach that Sandra talked about. And so from our standpoint, what we're trying to do is we know that there's people out there that have all these tools. How do we come up with an umbrella that says, look, there's a minimum of information you need to have in one of these tools. There's a minimum information in terms of what's the transparency of the information, how is it produced? How do we collect all these tools and come up with some guidance and standards around this? We've already been working on that around chemical hazard assessment. So Nike and Levi's did a great job in really pushing ahead with this faster than we could as a group to come up with a chemical hazard assessment, to look at their entire inventory of chemicals and say, let's put a score on that. Let's put a score and let's really try to drive down the hazard, the inherent hazard that's in our supply chain. But then how do we take that concept and not just strictly settle on that and say, well, everyone always has to use that and it can never evolve, but how do we also put something together that takes into account that folks like ChemForward and what Patrick talked about, they have the hazard bands A, B, C, and F. That's very similar to a scoring of 0 to 50, or it's similar to the red, green, and yellow that people have. How do we put an umbrella over that and say there's multiple approaches to this? Everybody is going down this path, but there needs to be some commonality. They will eventually drive to be closer together, I think. But initially, we have to recognize that there's multiple people that have approaches, and they're not just going to turn around and say, well, okay, ZDHC says we should have a score from 0 to 50, and we've had red, green, and yellow for the last 5 years. They're not going to change overnight. We have to align people and give them a framework and the confidence that this is going to be an ongoing system. So again, next year, what we're going to do is we will open up a place on the gateway where people can display, starting with the chemical hazard assessment, the scoring that they have. We have to do that from an NGO standpoint. We have to be able to recognize other systems. We can't simply focus on one provider. We have to have a system that's open from the standpoint of not restricting that. But what are the desired attributes that we think that has and that we're building into it? It has to be technically defensible. So it has to, they all have to cover the same maybe 18 hazard endpoints. You can't have one system that has 3 endpoints and one that has 18. It has to be publicly credible. It has to be accepted by everyone. So a segment of the industry just doesn't walk away and do their own thing. It has to be commercially viable. We've got to have, from an NGO standpoint and for what we do, we have to have multiple service providers to do this. And there has to be some component of a self-assessment for companies like BASF that have large toxicology groups. I know Hewlett-Packard with Greenscreen for years did that, but there has to be some component of that with third-party checks on what they're doing. And then the consistent basis so people can compare and say, how do I choose between formulation A and formulation B? And again, making sure we're addressing potential risk when considering switching chemistries to avoid regrettable substitutions. That's at the heart of it all. We want to have these scores publicly available. We want to have reviews to make sure we're updating our methodology as needed, and it also has to protect the intellectual property of chemical suppliers. So that's what we're trying to do. We definitely want to go beyond the hazard assessment and are working towards that too. But this is the basis for what we're trying to do in terms of implementing more sustainable chemistry. So I appreciate your time and thank you very much.
Yeah, thank you, Scott. It's really amazing what you've built in what probably seems like a long time, but it really isn't a very long time based on where you started. So I have pleaded with Molly, who has given us permission to go a little bit longer to address some questions, but we will be kicked off the line in about 8 minutes. And for those of you who must go, don't worry, this is all recorded, so you could come back and listen to anything you might have missed by having to leave. So we'll have, I'd like to ask one question of the panel and ask each of you to look at the chat and pick a question that you might want to answer, because there are questions addressed to each of you in the chat. So my question for each of you is how, and please add your video, thank you. How do you recommend dealing with trade-offs with these multi-attribute sustainability comparison systems? Can you trade off something that's very toxic for something that's very carbon beneficial? Or how do you, within your company, how do you deal with trade-offs? Because with this complexity, we have to address that. Thank you. So how about starting with, we'll go in the order of the speakers. Pat? And you're on mute.
Yeah. No, it's a good question that's come up before, and in the context of like Greenscreen benchmark scores and even ChemForward with the ABC. I put it in the context of so you have the health and safety consideration, but then you have performance and price, and those other two are also really important. And so some of it has to do, in my opinion, it has to do where it's being used. Something that you're using a formulation, you're rubbing on your baby every day, you might look at differently than something behind a wall. So if there's very low exposure and it works the best and it's the least expensive, maybe there are no red flags, but maybe it's not the perfect score, then you go with that one. Whereas something where there's maybe potentially higher risk and higher concern because of, let's say, children's use, that maybe you go with the one with the higher, I guess the better score in that case. That's how I would look at it. Great,
thank you. Victor?
Yeah, I think echo some of those. I think there has to be a minimum standard, right, below which an alternative isn't viable. But then when you start getting into the weeds of comparing one with the other, I think from our perspective, that's where the purpose of the product and the purpose of the brand is quite important. So if you have a product that is all about saving water or hygiene, then you're going to need to focus more on water quality and ensuring that you're not polluting the waterways and so forth. Making sure, of course, that you stay above that minimum threshold. And I think then beyond that, it's about making progress. So even you might not have a perfect solution that answers all of your pillars, but where can you make a small bit of progress while making a big progress elsewhere? So incremental improvement is better than no improvement at all.
Great answer. Thank you. Sandra?
Yes, I wanted to echo that as well, because my first thought was continual improvement. We actually do quite a lot with ISO standards and management systems, and as long as you have continual improvement, you can't say I'm not doing it because I have to make a trade-off. You have to keep improving.
Great, thank you. Scott, anything you'd like to add?
Yeah, no, I think it's a great question, and I think it's where we were trying to go with with our sustainable, in addition to the meeting the MRSL and the hazard assessment. Is a lot of brands have made commitments around water, around energy, some around chemicals, and there really hasn't been any look at what are the trade-offs. And so I think what we're trying to do first and foremost is just at least understand what those trade-offs are and understand that there are trade-offs. And in our industry, some of the chemicals have multiple applications and uses And so, what might be an acceptable trade-off in one application, it may not be in another, because it's very process specific. But what we're trying to do is at least get the information out there, and from the standpoint of things like water and energy, at least have a common basis for comparison, so that when companies are reporting out on water savings, they're reporting it at least on the same basis, and somebody can then judge against another product.
Great, thank you. Molly, jump in when you have to kick us off, but if not, Pat, any last words you'd like to say, or comments questions from the chat you'd like to address?
Yeah. So one of the ones I think you asked one of them. The other one was about the lower exposures in consumer goods that may present a potential health concern. This is going back to the example that I used, and the question says, may present a potential health concern, and so I think we have to look at all of these studies very carefully because they could. I think in this case, a lot of the exposures were single and double digit parts per billion. And I know from experience that you can get some analytical artifacts once you get down to very, very low levels. So, is something there, is it not there? One of the products that showed up in a little bit higher levels, it was, in perspective, they were actually low levels, but also the substance has no real indications of any endocrine related concerns or other tox concerns. So you're talking about relatively very low exposures to things that don't have any major tox concerns. And I think if you're looking critically at studies like this, using things like Greenscreen assessments and ChemForward and other things that are available can be really helpful of kind of putting these things in perspective.
Thank you. Victor, any questions you'd like to address or comments you'd like to make?
I think there was a question from Lauren Brown around what drove us to incorporate some of these KPIs into our measure, but I think more importantly, and what I wanted to focus more on is on the motivators that could be shared with the community. And I think here, for us at least, it was a mixture of doing the right thing and the purpose of our products. But then there's also an aspect of resiliency. So we're seeing retailers ask those questions of us and wanting to drive that, again, in response to consumers' desires, and going beyond just reacting to regulation and reacting to external pressures, and actually trying to preempt that. And that crystal ball that Sandra talked through, being able to preempt some of those pressures and understand where those future risks are going to be, where those future concerns are going to be, allows us to then innovate out of those rather than having to reformulate out of them. And innovation is always better than reformulation. It's cheaper, it's more impactful, and is all round a better option. So I think that's probably one of the key motivators, and that I think is that drive for innovation, which I think also echoes what Patrick was saying earlier.
Great, thank you. Okay, I apologize. I got the text from Molly. We have to stop. Thank you all so much. Really excellent presentations, really nice flow. Great job. Thank you for joining us from your holiday, Sandra. Wonderful job, everybody. Thank you so much. Okay, Molly, back to you.
Thank you for having us.
Yep. Please turn in 20 minutes. We will start session 6. The future needs of alternatives assessment and the A4, same URL, same place. See you in about 20 minutes. Thank you all. Bye-bye.